everyone, and welcome to this month's Department of Energy Python Exchange. My name is Cameron Riddell, and I'll serve as your host for this morning or afternoon, of course, depending on where you live. I think for our guest Marco, it's quite late right now. But to get the ball rolling, I wanted to introduce Marco Gorelli, who is here to speak on behalf of a project that he works on, Narwhals. Marco is the author of Narwhals and a core developer of Polars and a senior software engineer at Quansight Labs. He wrote the first complete Polars plugins tutorial, teaching thousands of students how to write Rust code to extend Polars functionality. He has a background in mathematics and holds an MSc from the University of Oxford and was one of the prize winners in the M6 forecasting competition. This month, Marco is here to discuss Narwhals, a lightweight compatibility layer between dataframes and how it's silently changing many of the data science tools that you are already using. And Marco, I'm very excited to have you join us this month because this is also a project that I have personally contributed to, and I have seen it been adopted in many widespread open source tools. But Marco, why don't I turn the reins over to you and you can tell us all the things that you want to share with Narwhals.
All right. Thanks, everyone. Thanks, Cam, for having invited me. Super excited to be here. I'm Marco Gorelli, happy to talk to you about Polars and the Polars API, and in particular, Narwhals today. I'm a huge fan of the show. I really liked the last episode where Gael did some nice live coding, so I figured, well, let's do the same. Live coding has the tendency to go wrong, but it does make things a bit more exciting. So let's give it a shot. Haven't prepared any slides. Instead, I've got some Marijuana notebooks that I'm gonna be sharing some material on. So let's just make sure I've got the chat open as well so I can see. Yeah, I think it's good if online events aren't like exact repeats of PyData talks. So going to offer something a bit different here. Gonna live code, gonna keep the chat open, see what people might be commenting. And yeah, at the end of the 20 minutes or so, I'm gonna give it up to the panel discussion. So yeah, focus of today's talk. I presume my screen sharing has successfully started. If not, please let me know. Focus of today's talk is going to be Narwhals with me, Marco, from Quansight Labs. Narwhals is a lightweight compatibility layer between dataframes and is used by several open source projects you might have heard of, such as Altair, Plotly, Marimo, Hierarchical Forecast, Shiny, Bouquet, Formulaic, Darts, TabMat, and several others. It's very exciting to see this list keep growing. I'm going to start with a little motivational example to try to motivate to anyone who's never heard about Narwhals why perhaps you should care about its existence. Then, for anyone interested in using Narwhals to build a data frame agnostic tool, I'll give you a very quick Narwhals crash course. And then, because this is the Python Exchange, we're not going to stop at the basics. We're going to go a bit deeper, talk about lazy execution and order dependence, some slightly more advanced topics you might not necessarily need to know, but I think they're interesting to think about and talk about, so gonna do a bit of that. And then finally, for anyone wanting to build tools on top of Narwhals, we'll talk about stability and Narwhals' backwards compatibility promises. And then finally, what comes next? What are we cooking? What can you expect from the project? Right. So first of all, little motivational example. I'm going to start by making a little plot using one of my favorite visualization libraries, Plotly. Okay, so far so good. Live coding is all right. It's executed the plot. We can see it. Interactivity is working. So just to go over what we've done, we've used the probably number one most used pandas function in the world, which is pandas.readCSV. We then filtered this data frame on the rows where symbol is either ABBV or XOM. These are just two asset names, not too important. But the main part I want you to focus on is the last line, in which we take our pandas data frame, pass it to Plotly, and then Plotly displays a beautiful interactive visualization. It's really nice to me that with just one line of code, Plotly can make such a nice visual where we can hover over points, zoom in, do lots of cool things. Okay, now let's zoom back out. Except we used pandas. And I think if you've been paying attention to the data ecosystem in the last few years, you might be wondering, well, what if I don't want to use pandas? What if I want to use polars instead? Or DuckDB or something else, That's not just pandas. Right. Glad you asked. Let's see what happens if we pass a polars data frame to Plotly. And you'll notice that now Plotly can also display this data frame. Now, up until last year or so, Plotly got around this by just converting non-pandas data frames to pandas and then displaying those. And this had some downsides, such as that converting to pandas isn't a free operation, like it's not necessarily zero copy. I mean, it is in some cases, but it's not in general. It avoids some of the performance benefits that come from polars. And it requires polars users to have pandas as a dependency in any project where they want to visualize their data. But now, I just want to demonstrate how far things have come. I'm now going to remove pandas from my environment. Let's remove PyArrow as well, just to really drive the message home. Then let's comment out the pandas cell, because that's not going to run anymore. Let's restart the kernel. Yeah, let's restart. Run the whole thing. And you'll notice that even though we don't have pandas installed, Plotly is still able to display our polars data frame. A quick note for anyone who's not familiar with this Jupyter-like environment that I'm using. This is called Marimo. It's intended as a better version of Jupyter. And one peculiarity of it is that when you write a cell, the output is displayed above instead of below. So if anyone's confused about that, just thought I'd explain. It's something I quite like. They think of it as like the output, and then the code is just the caption of the output. Anyway, we're going to be having outputs above the code. So there you go. Plotly is now able to accept either pandas or polars without either being required and without any data frame conversion happening between them. The reason they're able to do this is because Plotly uses Narwhals, which, as we said at the beginning, is a compatibility layer between data frames. In a nutshell, the way you use Narwhals to write data frame agnostic code is, first of all, you call from native on the user's input. Ignore this gibberish. Looks like something went wrong with my attempts at speeding things up using Vim key bindings. Then you express your data frame logic using the Narwhals API. And then finally, you return the object to the user in its native class using narwhals.toNative. Now, I don't want to just leave you with a recipe and not show you what it tastes like. So let's now give a demonstration of how to write a data frame agnostic function using Narwhals. But first, let's restore our environment. Let's put pandas back, and let's put PyArrow back. It's amazing how far Python packaging has come. Truly incredible where things are now, thanks to UV and others. Right, let's restart the kernel just to make sure everything's available and loaded. So say that we've got a nice little vegetables.csv file. And we've got some colleagues. We've got Paul, who really likes to use pandas. We've got Paulina, who really likes to use polars. And we've got Dominique, who really likes to use DuckDB. And we'd like to make a pre-processing function for our dataset. Like we'd like to maybe, you see, we've got lots of products. We've got our farm price. We'd like to maybe only keep rows where we have tomatoes, carrots, or potatoes. And then we'd like to strip the currency from farm price. And instead of having it as a string, we'd like to have it as a number. So then we can say normalize it or scale it. So that is to say, subtract the mean and then divide by the standard deviation. And then let's only keep the product name, farm price, and date columns, sort by date and product name. And the hard part is, this function should work for pandas, polars, and DuckDB. All right. Now, if you were given this task, one first attempt might be to write a different logic for each library. So if you accept some data frame, then you can say, if that data frame was a pandas data frame, then we use the pandas API. So we use .lock to filter on rows. We use .assign and then string.lstrip to make a new column. We use assign and then another lambda to scale a variable. Select columns with square brackets, sort values. And then you need to translate this to polars. Okay, so we use filter instead of .lock, is underscore in, use a strip chars, with columns again, select, sort. And then finally for DuckDB, we need to write some SQL, not the simplest SQL query ever, but nothing crazy either. We just have a common table expression. We need to use regex replace instead of like string.strip chars. And then to do a comparison between a column and its mean, we need to do this little over nothing. So this is we're defining a window function because SQL doesn't let us compare columns with aggregates. The aggregates need to first be over, in this case, an empty window. All right. Yeah, I don't think I need to justify too much why this is not a desirable solution to maintain. It quickly gets out of hand. So another solution could be just whatever the user passes in, we just convert that to pandas, and then we just use the pandas branch. That's also not ideal. Like if a user passes in a polars data frame, they probably want to get a polars data frame back. So let's look at how we can make a data frame agnostic version of this function that we can still pass pandas, polars, and DuckDB to and get the same results, but without having to duplicate our logic 3 times. So duplicate 3 times maybe should be triplicate. Nonetheless, here we go. Let's look at how it can be done. So instead of clean dataset, I'm going to call this agnostic clean dataset. And the 3 steps for writing a data frame agnostic function with Narwhals are from native, Narwhals API, and then to native. So let's rename df to df native just to make sure that this is to make it clear, this is the native data frame that the user passes in. We're then going to convert this. We're going to wrap this in a Narwhals object using nw.fromNative. Let's get rid of the pandas logic. We don't need that anymore. And then the polars logic, we are going to modify that. Let's get rid of the DuckDB one either. Now, when I say use the Narwhals API, the Narwhals API is really just a strict subset of the polars API. So if you already know polars, then congratulations, you know Narwhals as well. Let's just take a look at how this works. I'm going to make a temporary variable called result, and then I'm going to return result.toNative. I also need to take care to replace PL with NW. Let's see if we can find all those places. And because live coding always goes wrong, I'm virtually certain that I'm going to forget at least one. Nonetheless, well, let's see, is this going to work? I always get really nervous when live coding just before executing a cell, but I'm feeling fairly confident about this one. We've just wrapped df native in Narwhals. We've used the Narwhals API, and then we're calling toNative. Okay, no errors when just defining the function. Let's see if we're able to pass our different data frames to it. So let's start with pandas. So I'm gonna pass this one to agnostic clean dataset. So with pandas, okay, we get the same output as before. Nice. Let's see if it works with polars. All right, works with polars too. And then finally, SQL solution. Let's see if it works with DuckDB. And yes, works with DuckDB as well. There is a little trick I need to reveal here. Need to be completely honest with you all. I'm using a pre-release of DuckDB 1.3.0, which is not yet out yet. It'll be released in May. Nonetheless, there are some features from the upcoming DuckDB version that we need to get this to work in Narwhals. So for the demonstration, I'm using the pre-release. All right, so that's Narwhals in a nutshell. This is how we define a data frame agnostic function we just define our logic once and start with from native, end with to native. And as far as the user is concerned, everything is just working natively on their library without them having to care about other dataframe libraries. Now, again, we're at the dataframe exchange, so let's go a bit deeper and let's talk about order dependence and laziness. Because of the objects that we looked at so far, so pandas, polars, DuckDB, there is an elephant in the room we need to talk about, and that is eagerness versus laziness. Because pandas is purely eager. Every operation just is executed the moment that you tell pandas to do it. Polars has both an eager and a lazy engine, whereas DuckDB is completely lazy. Everything is deferred until you decide to collect it into an eager data frame. So how can we make an API like Narwhals which supports all of these together? Well, the answer is that in Narwhals, we distinguish between eager and lazy. So we've got two main data frame classes in Narwhals, which are dataframe and lazy frame. Dataframe assumes that all the data is in memory and that row order is well defined. And one consequence of this is that NumPy style indexing is defined. Like if you've got a Narwhals data frame, it's perfectly well defined to say, okay, give me the first, the third, and the fifth rows. The same cannot be said about Narwhals.lazyFrame. A lazy frame might not be in memory, like execution can be completely deferred, and row order is undefined. Asking for the first row of a lazy frame is like asking for the first element of a set. It's not a well-defined operation. Row order is just not defined. The other two classes we need to talk about are expressions, which you can use with both dataframe and lazy frame, and then series. A series is a one-dimensional structure, and it's an eager-only concept. It can only be used with Narwhals.dataframe. Let's look at a couple of concrete examples of where dataframe and lazy frame differ. So the first is indexing, and the second is window functions. Let's start with indexing. I've got some code here. I'm going to create a couple of objects. So df, this is a Narwhals data frame backed by pandas. And then lf, this is a Narwhals lazy frame backed by DuckDB. Now, for the lazy frame, it might look to you like the rows are in a certain order, but this cannot be assumed in general. Whereas for the data frame, the rows are in the order that they're being shown to you. Let's look at the consequences then. So for the data frame, if you want to select, let's say, the first and the third row, easy. Just index into the data frame as you would, say, into a NumPy array or into a list. No big deal. For the lazy frame, however, if you try to do that, you'll get an error, like slicing is not supported on lazy frames. What you need to do instead is use expressions. So if you wanted to keep these two rows, maybe we could do the filter using the date column. Like maybe we could say .filter and w.call_date is, look at how nicely autocomplete works. So if you keep your API simple and make good type annotations everywhere, then your editor can really help you be productive. We've put a lot of effort into good developer experience in Narwhals. So let's keep all of the rows where the date time is either the 25th of March, 2025, or the 27th of March, 327. All right, here we go. And now you'll notice that this operation can also be well supported. So for the data frame, row order is defined, so we're allowed to just index things positionally. In the lazy frame case, there's no such thing as positional order. So the way to filter data frames is based on expressions and based on conditions. This is a restriction, it's true, but in turn, it means that lazy engines don't have to assume order. They can be free to rearrange results if they need to in order to enhance performance. It means that they can follow streaming models and they can scale a lot better than purely eager implementations. Right, so that was indexing. Let's talk about window functions. And the window function I'll use for this example is called the cumulative sum. So for anyone not familiar with that, that's just a sum which keeps on accumulating. Like say we've got the elements 1, 4, 2, 5, 7, 8. A cumulative sum would be 1, 5, 5 plus 2 is 7, 7 plus 5 is 12, 12 and 7 is 19, 19 and 8 is 27. If I got any of that wrong, please don't clip it out of context to embarrass me. I'm not very good at arithmetic. It's one reason I like programming, because then the computer can do the arithmetic for me. Right. Let's try to compute this cumulative sum on both a data frame and on a lazy frame. Now, on a data frame, let's display it again, just to remind ourselves what it looks like. Let's put this in a separate cell as well. There's no issue, like a cumulative sum. Yeah, let's just calculate the cumulative sum. So price cumulative sum, I'm gonna say column price dot cumulative sum, and we should get 4, 9, 15. And indeed we get 4, 9, and 15. You can also compose this like with an over command. So we could just reset the cumulative sum when we switch store. So like this, within store number 1, the cumulative sum happens like 4, and then 4 plus 5 is 9. And then in the second store, the cumulative sum happens here separately. So there's just a single row, so the cumulative sum is just 6. If we try doing the same operation on a lazy frame, you'll notice that this isn't actually supported. You'll see that we get an error from Narwhals telling us that order-dependent expressions are not supported for use in lazy frame. And it gives us a couple of suggestions, but one in particular is to use order by. Okay, let's try using that. So we're going to say here order by equals date. And now take a look at that. We are now able to compute the cumulative sum even in a lazy frame. Things are allowed to happen in order in a lazy frame. They just can't happen in physical order. If we want to do a cumulative sum, we need to be very explicit and say, okay, I want a cumulative sum evaluated in the order defined by the date column. Whereas for data frame, it can just happen in the physical order that the rows are defined in. So there you go. That's a big difference between data frame and lazy frame. And which one you choose depends on which kinds of libraries you want to support for your application. If you're making a visualization library, maybe you're primarily going to target eager libraries. Whereas if you're making a feature engineering library, then maybe you'd be interested in supporting lazy libraries. And on the topic of building libraries on top of Narwhals, let's talk about Narwhals' backwards compatibility policy. I really don't like having dependencies, and I like it even less when dependencies make breaking changes. But unfortunately, that's just the way that things go. Like, you either keep your API exactly the same and never make improvements, or you go through deprecation cycles. Like this, whatever you do, it's going to annoy someone. What we do in Narwhals is to try to minimize the disruption caused by changes in deprecation cycles is we expose 2 namespaces. So we've got the main Narwhals namespace, which may be subject to changes in deprecation cycles. And then there's the stable.v1 namespace, which is not expected to ever change, so long as Narwhals is around. This idea is inspired by the additions concept in the Rust programming language. The general advice I give is like experiment with Narwhals, the main namespace, because that's more convenient. And then once you're happy with that, see if you're able to switch out import narwhals as NW to import narwhals.stable.v1 as NW. And if it still works, then you can deploy your confidence. You can deploy your confidence. You can deploy your tool with confidence that new narwhals releases won't break your tool. Let's give a quick example. Here we've got our previous function agnostic clean dataset. And the way to use the stable API is to just use import narwhals.stable.v1. And in this case, it all just works exactly the same. But we're promising that we're not going to deprecate the code that you wrote. So if you're able to express your operations using stable.v1, then the promise we make is that indefinitely going forwards with new Narwhals versions, we're going to keep it working. As long as it's feasible. Like if downstream libraries make crazy big changes that we just cannot work around, then, well, yeah. There are going to be cases that maybe we won't be able to do anything about, but as long as it's feasible, we promise to maintain backwards compatibility. So in conclusion, what have we talked about today? We talked about how Narwhals is a lightweight and extensible compatibility layer between data frames. It's used by some major open source projects like Altair, Plotly, Marimo, Hierarchical Forecast, Shiny, Bokeh, and more, and has an active developer community, and has received high-quality contributions even from people in this call, like Cam, who gave the introduction earlier. We also saw how to use Narwhals. There's really just 3 steps. So call from native on the user's input, then use the standardized Narwhals API, and then finally return the object to the user using toNative. Now, next steps. What else are we excited and working on? I'd like to stabilize some things into narwhals.stable.v2, which can correct some of the design mistakes we made in narwhals.stable.v1. My hope is that stable.v2 can be the API, which is just going to stay around essentially for a long time. I want it to be a bit like NumPy version 1 that was around for, I can't remember how many years, but I think it was more than a decade before they finally moved to NumPy version 2. Like, when we declare narwhals.stable.v2, this one we should be really happy with. I'd also like improved support for lazy-only backends, like in particular DuckDB, PySpark, SQLFrame, and IBIS. And finally, the most exciting thing is to spread Narwhals, Narwhalify more libraries, and make the future of data science more data frame agnostic and less locked in to just pandas. Pandas is an awesome library, but there's not just pandas. There's other libraries out there as well. And it's a pity if everything is locked into pandas. Thank you for your attention. Thanks again, Cam, for having invited me. This was a lot of fun. Happy to take questions and take part in the panel discussion.
Absolutely. Thanks so much, Marco. An excellent presentation. Now, if you have questions or thoughts in the audience, please do use that Q&A widget or use the chat if you simply want to leave a comment. But with that being said, while we wait for some of these questions to roll in, I'd like to invite our panelists. If you have any questions or thoughts about applications for Narwhals, we'd love to hear them.
Sure, I'll kick off. The first thing I'm curious about is, is there a both an opportunity for the Narwhals conversion of eager to lazy or lazy to eager? And are there use cases where that's actually relevant or your best holding to the paradigm you're importing from?
Yeah, fantastic question. Yeah, so I think Plotly is a good example because they do both, actually. So if they receive a lazy data frame, well, so first we need to note something about Plotly, which is that they don't return a data frame to the user, they just display it. So in the from native Narwhals API to native part, for them it's more like from native Narwhals API display. So they don't need to worry about exactly preserving the class that the user started with. So what they do is if you pass them something lazy, they consume it in the same way that like a Python function might consume a generator, and then they can display that. So they do the conversion in one step. So if they start with something lazy, they do collect it and end up with something eager. But there's also another part where they chain together several data frame operations. And so on the first one, they call .lazy. Then they do all of these data frame operations together and then do collect. Now, there are some libraries that don't support lazy execution, like pandas. So for pandas, this is all going to be eager anyway. There's no performance benefit. But for libraries that do support lazy execution, like Polars, this means that it's potentially able to make some optimizations and end up with better performance.
Awesome. Thank you.
Oh, okay, I can go next. Thank you, Marco. Very interesting presentation. Could you please elaborate a little bit on the internals of Narwhals? How does it work? Maybe just a few insights. Maybe to guide your answer, what I'm interested in. Is there some unique internal representation for native sources from different data frames, or are they different for different natives? How do you convert between them? What is this internal logic
Yeah,
of
sure.
unifying the API?
Yeah. So in Narwhals, internally, it works with the three different layers. So there's the top layer, what we call the Narwhals layer, and this is what users interact with. So anytime you're writing nw.col, yeah, that's the Narwhals layer, Narwhals expression. Internally, that then gets mapped to what we call the compliant layer. So this is like an intermediate representation in which we wrap all of the native libraries into a standardized API. So then below the compliant level, there's the native level. So these are literally the native objects. Could be a pandas data frame, a DuckDB Pi relation, and they've all got their own different APIs and different ways of doing things. So the intermediate part, the compliant, that one, yeah, that's the intermediate representation. At the Narwhals level, we're doing a lot of tracking of metadata and metadata resolution, because different expressions can be combined together in some ways, and we need to impose certain restrictions based on whether they then get evaluated in a eager or in a lazy context. For example, order-dependent operations in the lazy context need to be followed by over with order by specified, whereas in the eager context, they don't need to. They can just happen in order of appearance. But we also need to support specifying order by in the eager context in case somebody wants to do that as well. Hope this answers your question, but if there's other internals you wanted to ask about, we do have a page in the documentation called How It Works. Essentially, when I started Narwhals, I really wanted people to contribute to it, and thought a good way to try to do that would be by being fairly transparent about how it works. Sorry, I meant to post that to everyone, not just to panelists. Here we go, this should be the right link. So yeah, if you're curious about what's going on underneath at the intermediate representation there, this should demystify things.
Awesome. Thank you. Theory sounds exciting.
Cheers. Yeah. No, there are really parts when we were almost like working out mathematical theorems, like, is it true that this invariant always holds? And then we go through the different possibilities and like, yeah. One day you're going to have to write a paper, really theorem, lemma, proof style. James.
I think one of the simplifications we make when we talk to end users is we tell them that there are library authors and library users. So for example, when we're teaching them Python for the first time, we say, if you're a library author, you need to learn how to write decorators. But if you're a library user, you just need to understand what that syntax means when you use decorators. But in truth, there are library authors at many different levels. Like even normal scientific users want to share their code with others. And from this framing, I'm very curious, what is the intended audience for Narwhals? How much of a library author do you need to be before this makes sense? If I'm just a single scientist writing a little bit of code that does some analysis better, and I share it with 20 colleagues, am I a big enough library author to make this worth my time?
I'm slightly biased, but I'd like to make the case that it is worth your time, because if you use native APIs, you need to worry about things changing when the library makes new releases, whereas with Narwhals, we promise to do all of that testing for you. The API is fairly simple, so it's quite difficult to shoot yourself in the foot with Narwhals, whereas I think, well, you're probably the #1 expert in the world on this, on how to write bad pandas code. I think you know a lot of gotchas with pandas that people run into and make code that could be efficient, really inefficient. You go full circle and you teach people then how to make it efficient. But in writing Narwhals, we were, like for us, pandas was a fundamental library to support. Like we really wanted the overhead on top of pandas to be as low as possible.
When putting this in front of users, how do we get over the hump that it's just one more thing they have to learn, especially in cases where they're already somewhat reluctant to even learn what's sitting underneath that because they're so worried about being distracted from the underlying scientific work they're going to do?
I think that one afternoon learning a strict and unified API now can potentially save you hours of debugging down the line. So it depends how long-term versus short-term you need to think. And sometimes the right thing to do is to think short-term. Like sometimes you need to hit a deadline next week, and the right thing to do is think short-term. But I'd also encourage people to make decisions based on the long-term when the circumstances permit that. Perhaps one more comment on the distinction between library author and user. When I started Narwhals, I thought it was going to be just for library authors. But as we've started supporting PySpark and DuckDB and Dask, I've really started to appreciate that maybe we've come up with a pretty nice front end to those tools.
So would you even encourage end users doing ad hoc analyses in a Jupyter notebook just for themselves to go through Narwhals rather than through whatever interface of the thing that's sitting right there in front of them?
Potentially. It depends how familiar they are with the Polars API compared to whatever engine they're looking to use. Personally, I'm not very good at writing SQL, so if I want to use DuckDB, then the prospect of using Narwhals is quite appealing to me.
As you were talking, that was the first thing I was thinking about. I was like, oh, a way to never write another SQL query again. What a joy. But to that end, is there some flexibility that we lose by adopting a generic or singular API that stays very fixed, right? So is there a world in which Pandas create some new innovation that changes the face of particular operations that then become inaccessible to a translation layer, and then you are forced to go into the pandas layer to do this very intricate operation? Or do we just assume that, right, tables are tables, and we've been staring at tables for decades, and they'll always be tables, but just different, faster ways of munging them?
There's definitely always trade-offs. There are things that DuckDB can express that just aren't accessible from the Narwhals API. There are things Polars can do that we can't. There are things Pandas can do that Narwhals can't. So it's definitely not intended to be the last dataframe API you'll ever need to learn. It's not intended as a replacement for anything. So yeah, I agree. Like,
I think
there are trade-offs.
I think an easy example of that is group-weighted summary statistics are nearly trivial to express in SQL in DuckDB, but are an absolute nightmare to express in Pandas. And I don't know, maybe Cameron knows if they're easy to express in Polars.
Marco knows as well, because I know, Marco, you've actually written a blog post on this type of problem. But Polars, because of the optimizations of the lazy frame that it can apply, it can take your queries that you're putting in a group by ag, and it can intelligently apply them. Whereas Pandas, you need to manually pull some of those queries out of the group by operation if you want it to go fast. But then, of course, it's based on the volume and the number of groups that you have. So there's a lot to think about with Pandas. Whereas Polars, is the optimization layer going to make the best pass? Probably.
Yeah.
But this is actually a great question, James, because Marco, I do have a follow-up on that, of how does Narwhals deal with, or does it try to, I use the Narwhals infrastructure using what I know about Polars, and now my data frame code runs really slow because I'm using Pandas, and I'm not taking consideration as to the eagerness that Pandas has, and I accidentally wrote some really bad Pandas code. Is there anything that Narwhals does for that?
Sorry, I'm not quite sure I understood the question, sorry.
So if you use Narwhals to write some data frame code, and you plug in a Pandas data frame to that code, and it runs really slow, because maybe you did like a group by mean inside, or a group by mean minus without transforming first.
Sure, yeah, sorry, got you, yeah. Yeah, okay, so first of all, I recommend that people admire a little Easter egg we have in Narwhals, which is you can do from Narwhals import this, and this will show you the Zen of Narwhals. So just some philosophy behind the library. And one of the lines in there is a good API is an honest one. So generally speaking, if something is available from the Narwhals API, then we make the promise that this is mapping natively to the underlying library, and we're not like iterating over groups in a Python for loop. So if you write something, so again, in theory, anything you write using the Narwhals API should get translated efficiently to pandas with little or sometimes even negative overhead, because we're very careful to avoid unnecessary copies and unnecessary resetting the index. There is one case that you mentioned, which is in group by aggregations, where pandas is less flexible than in other libraries. So in that case, if we do need to use .apply, then we emit a very loud user warning, just saying, look, we've had to fall down to a non-elementary aggregation. If you want to make this warning go away, then, well, either don't use pandas or rewrite your code such that you're pre-computing some of the steps, and then your aggregation within the group by is an elementary one, like just .mean, standard deviation, one of the single elementary aggregates.
I really liked one of the things you mentioned there of pandas code can be hard to get right, but we have written a lot of code for you to make sure at least like some of the parts are right. You can still assemble them in a way that is horrible, but if you're just using these individual parts, they're at least well written because the people who are working on this are quite familiar with pandas.
Yeah. Thanks. I saw there was a question in the Q&A. Should we take this?
Absolutely. So to read it out loud, with dropping support for pandas, how could you see that one supports narwhals here? So I'm assuming this individual may be dropping support for pandas for some library they're working on, and they're wondering, could narwhals be the replacement? Because maybe just going from pandas to polars or pandas to DuckDB could be a tricky maneuver in the future.
I think there's a good example of this happening right now, and that is FairLearn. That's a library that came out of the scikit-learn ecosystem. And they're not too happy about depending on pandas, partially because they weren't happy with some breaking changes that happened, and partially they weren't happy with PyArrow potentially becoming a required dependency. So they're now in the process of rewriting their dataframe logic to use Narwhals, and then they're evaluating which engine to choose by default for users, which is probably going to be polars, because they're doing some eager operations. So I don't think they'd be able to do everything with DuckDB. But that's the idea.
Yeah, and I know that
Hope
was,
that
that was
answers
a big concern for a lot of libraries was a lot of users wanted pandas supports, but not a lot of libraries wanted pandas as a core requirement for their particular project. And so Narwhals kind of hits that sweet spot where it's much more lightweight than a full installation of pandas or anything related.
Cheers, thanks. Yeah, and at the beginning, in the early days, it was very difficult for me to communicate this to people for some reason. Like the common questions that people would be, yeah, but just convert to pandas. Like, what's the issue? Well, it's a missed opportunity. That's the best way I can describe it.
It occurs to me that the sweet spot for this might be something that I don't have a lot of experience with. I'm guessing Phil probably has the most experience, which is, as I understand it, there are thousands of machine learning libraries out there, the goal of which is not to implement a machine learning algorithm, but to help somebody with a specific use case in the terms of that use case with some machine learning underneath. And it's my understanding that the entry points for all of those are phrased in terms of the actual use case. And all they really do is one or two operations, pull this column out of this data frame, do this simple filtering on this very, very simple stuff, and then they dump it into PyTorch, dump it into scikit-learn, and then spit the results back out. And then the user does all of their additional data munching at the surface level, not inside the library. And so from that perspective, they would be swapping out, one or two very panda-specific things for one or two narwhal-specific things. The amount of narwhals code would be relatively minimal because, again, as I understand, they don't really muck about that much in the data frame. They just want to pull the data out and stick it somewhere else and then move on with their lives.
Absolutely, yeah. We see, I think hierarchical forecast from Nixler is a good example of that. And Narwhals really just started with the observation that a lot of data frame consuming libraries, a lot of data science libraries aren't doing anything that crazy with data frames. And so just being able to make a compatibility layer that's enough to address those needs seemed like it was achievable.
What's the average quality of these use case specific machine learning libraries?
Quality according to what metric? Like how useful are they?
I don't know. I saw Phil smile, so he knows the answer. He just doesn't want to say it.
I often, right. This is a qualitative
He's
question,
gonna
but
say it varies.
I would say it varies. I say often my litmus test for when somebody passes me something that says, "Look at this thing. It's going to make your life a lot easier because you're more familiar with the domain than the nitty gritty." I mean, right now, a great example. Marco's telling me, "Look at this tool, Narwhals. It's going to make your life a lot easier when somebody hands you a DuckDB and you don't want to deal with it." The first thing I do is navigate to the GitHub and count the number of active contributors. And if it is greater than 1, I'll stay around and look. And if it's greater than 10, I may install the tool. And I think that is a good litmus test for how useful it is, right? Because it's not just useful for one person who says this is important, but it's useful for enough people to use and then say, I care about this thing, so I'm going to contribute upstream. Or my boss cares about this thing and is paying me to contribute upstream, and therefore there's capital behind it. So one of those two cases tends to be satisfied, and that's how I determine whether or not I will spend a lot of time looking at a convenience library. So Marco, I think you've passed the test. Congrats.
Cheers, thanks. I actually did a bit of growth hacking in the early days. Organized a few like beginner sprints where we had like lots of good first issues, and I was like, you know, if you can get a lot of people to just address one simple thing, then the number of contributors on GitHub is going to grow. Anyway, we did just surpass 100 unique contributors on GitHub. Need to celebrate that with a reaction here on the call. Unfortunately, that 100 does include a couple of bots. So draw whatever conclusions you will about robots taking our jobs. And please do feel welcome to contribute, Phil, if that interests you.
I will at the very least give it a run out.
I would advise you that passing the pre-commit checks is getting harder and harder because of how much heavy use we're making of static typing these days.
I can cope with that. That's
Yeah.
I'm glad you
a
can.
welcome pattern, which I know some people disagree with, but I think while many people will say Python is duck typed for a reason, I miss some old languages and still use them for that reason.
Yeah. Static typing prevented me from introducing a bug in Altair. So since then, I'm always like, okay, as much static typing as possible everywhere.
You're recently playing with what's that new static type checker?
Oh, this Firefly.
Yeah, I hadn't heard of that one until you had brought it up because it's felt like everyone was just getting to Pyrite.
Yeah, exactly. So this is a blazingly fast type checker that Meta are putting out. I say blazingly fast because it's written in Rust, and everything that's written in Rust has to be blazingly fast. That's the law. And indeed, it is blazingly fast. It type checks narwhals in just a few milliseconds. Unfortunately, it's not particularly useful at the moment because there's hundreds of false positives, but I've reported these false positives to them. And they say that, yeah, later this year, they're presenting it at PyCon in May. So hopefully later this year, it should be in a usable state. And yeah, super excited about that if we can have a fast and accurate type checker.
Broadening the discussion a bit, I'm curious, a lot of the users that we interact with, maybe in the early parts of their scientific career, had to learn C or C++ in order to hack on some code that some postdoc previously wrote. And then they switched over to Python, and it was a breath of fresh air for them because they don't really want to be programmers, but they need to get some work done. At what point do these folks need to consider perhaps learning a little bit of Rust, or is that something which really always will sit at the library level for this population?
Oh, I'm glad you asked. I've actually written a little tutorial on how people can extend polars with with Rust plugins. And my claim is that it's a lot easier than you think, and it's also a lot more fun than you think. And that the amount of Rust you need to learn to extend polars so it can carry out whatever complex bespoke calculation to your particular domain is relatively low. So I don't know exactly at what point it is that people might need to consider learning Rust, but I presume it is do however much you can using native APIs from Python. And when you just can't go any further, then maybe take a look at Roost. Or Rust, as it's more commonly pronounced.
Margot, I have a question for you. And I'm curious because when I first heard of Narwhals, I was thinking, well, isn't IBIS already a thing? And so I'm curious, how do you differentiate from kind of one of the originals of we're going to make one API and have backends for everything else?
Yeah, when I first heard about IBIS, I was kind of hoping that IBIS would do what Narwhals does. But I didn't have much luck convincing them to drop pandas and PyArrow as requirements for all of their backends. I didn't have much luck asking them to make a two native. Like you can go from any backend to an IBIS table, but then getting back to the underlying object isn't trivial. Like you need to convert to SQL and then pass that to the underlying object. So yeah.
So it's a little more heavyweight than you were envisioning.
Yeah, exactly. Like way more heavyweight. I just thought, let's make the most lightweight possible thing. So that was one. Yeah, that's one difference I see. A second one, and this is purely subjective, but to be honest, I really don't like typing ibis dot underscore open square bracket. Like it just makes me feel uneasy. So I wanted something closer to the Polars API. And finally, yeah, IBIS is really focused on lazy execution, whereas I think most use cases for Narwhals are eager. So IBIS dropped support for Pandas and Dask, whereas for us in Narwhals, Pandas is like I'm not saying it's the number one priority, but it's pretty close to being the number one priority to have good Pandas support.
Yeah, so it feels like IBIS is more lean towards the things that you're not necessarily going to be running long term on a desktop.
Yeah, exactly. I think
they, Pandas, they say that's too small,
Yeah, I mean, they do also support DuckDB, which you can just run on your desktop, and it's often good enough for a lot of jobs that people maybe previously would have reached for clusters for. Like, I think it's a good project. Narwhals is definitely not intended as a replacement for IBIS, just in case anyone gets the wrong impression. Definitely not intended as that. In fact, we also want to support IBIS in Narwhals, and there's an open pull request to do that. My hope is that by maybe the end of next month we can get it shipped, but it's not there yet.
That's the one for the IBIS lazy frame?
Yeah, exactly. That was a somewhat unlucky contribution in that they made a contribution just while we were in the middle of some pretty large refactors.
Yeah.
So there's going to be some painful merge conflicts to resolve there.
It's always fun. And then you got to type check them afterwards.
Yeah. Yeah, Phil, I hope that your opinion on type checking remains unchanged, even if you see some of the things that are going on inside of Narwhals. Generics on generics on generics.
Fantastic. Any final thoughts or questions from either our panelists or the audience?
Why Narwhals? What does the name mean?
It's from a song. Narwhals are swimming in the is it swimming in the ocean or singing in the ocean? I can't remember. Causing a commotion. And
Or like the eBombs world era.
yeah,
The
exactly.
old internet.
Okay, that's immediately what I thought. Like this,
Yeah.
it's been turning in my head this entire time. I've been trying to focus and just be like, no, no, walls. Okay, cool. Good to know. How does that
Well,
relate to the package itself, or is it just a good bit?
well, okay, full story. The original name for the project was Polar's API Compat. But then I figured, look, nobody's going to use it with such a boring name. So maybe we need an animal name because all successful data projects seem to be named after animals. And I thought, well, polars, pandas, maybe let's look for something that lives in the North Pole. Got polar bears. Let's look for something else that's that part of the world. Looked at the list of Arctic animals on Wikipedia and found puffin. I was like, oh, this is perfect. I would love to make a library called puffin. But puffin was already taken. Puffins is actually taken by some climate scientist and who's made a library that gets like 10 downloads a year or something nobody's using. And I wrote to this person saying, look, I really want to make a library called Puffins. Could you please let me use this on PyPI? And they said, yeah, I'm aware that nobody's using my library, but I really like it and I want to keep the name. It's like, okay, fine. I'm going to have to go down the list, look for the next Arctic animal. And narwhals, like the song. I guess we can call it narwhals. So that's, and now I guess we're stuck with the name. On the plus side, I've heard from a few people that they were not aware of what narwhals even were. Like they did not know this animal before they came across this Python package. So yeah, we are also doing some social good here by raising awareness about the narwhal animal, which is endangered. So save the narwhals, people.
Excellent. And Marco, before we wrap up, is there any final thoughts you want to share with our audience, or do you want to let them know how they can stay in touch with you, or you want to share anything that you're working on coming up that you want to invite everyone to?
I'm presenting narwhals at PyCon Germany next month. Other than that, really happy to take contributions from people, especially on backends like PySpark that I'm not an expert in. So yeah, any contributions towards PySpark and IBIS, I would really appreciate those.
Fantastic. Well, you heard it here first, all about narwhals from Marco himself. I want to thank everyone in our audience for joining and thank our panelists here for the invigorating discussion. I hope to see you all next month at our next Python Exchange. We have another fantastic guest panelist joining us, so make sure you stay tuned. Keep an eye out on our website. That's meetup.doepy.org, and I will see you all there. Thanks, everyone, and have a great rest of your day.